Here we go with our first lesson note section for chapter 2 in our trig and pre-calculus class. We're going to look at shifting functions and periodicity and at sigma notation. So let's get started. This one is shifting or transforming functions. So let's see, we've got how is Q a transformation of function P? So here's function P, and this is what function P looks like. And Q is a different function that has been shifted. Well, what is the shift? A +2 in parentheses with the x is kind of does the opposite action. It moves things to the left by 2 units. So use the graph here on grid A to graph Q of x. So we're going to take these points, all of these. I'm seeing key points here, 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 and here, and I'm going to shift each of them 2 units to the left. So new point, new point, new point, new point, new point, and there's the last one. Okay, so here's my shifted parabola. Oops. With arrows that go forever. And this kind of dips down a little bit between these 2 points. We don't actually have the vertex. So find an expression in terms of x for this right here. So basically we are plugging in for p of x the x plus 2. So q of x ends up being our p of x, but in place of each x, we put a big set of parentheses. And in those parentheses is the x plus 2. So this is an expression in terms of that, and we could also simplify all that, but this is good for now. We'll just leave it as is. All right, going on to the next one. Be sure to remember that you're taking notes on each of these in your math sketchbook. Okay, the graph of f of x is shown below here using the graph of x, f of x. Now let's sketch a new one, g of x, onto this grid and describe the transformations. So it looks to me like what I see is a shift 1 unit where? 1 unit to the right or to the left? It always seems backwards, so this is 1 unit to the right. And then for the up and down, it's always exactly what it looks like. So 3 units up. So that's what we're going to do. Take each of these key points and do that very same shift. 1 unit to the right and 3 up. 1, 2, 3. So this point here ends up here, and then in relationship to that, I've got another point here, 1 here. This vertex here, 1 up, 1 to the right and 3 up. 1, 2, 3. Ends up right here. So I've got this curve. This goes down to this vertex here. I keep missing it. My pen is not very well lined up. Okay. And moving on to this one. Most of us are comfortable with shifting parent graphs. That's what we just did. But how does it work the same way to shift a piecewise function that we recently learned about? Sure. So first what we need to do is sketch this on our grid. So I've got kind of a dividing point at 2. So I want to figure out what the value of x squared is at 2. Well, 2 squared is 4. And the value of this function at 2 is also 4. So I know that they are going to link together at the exact same place. And they're going to divide from one to the other at where 2 at 2. So that's kind of right here. So my parabola exists everywhere below 2. And that parabola is not shifted at all. It's got a vertex here. And so there's my parabola. And this one is a line with an intercept of 2 and then a slope of 1, so it connects right here with the solid dot. The other one had the open dot, but the line has the solid dot, and we go up with the slope of 1. So there's our sketch. Let h of x, our new function, be what we get when we shift it over. And let's shift that over. Let's do that in a different color. So let's shift this one over to the right 1 unit. So this ends up here, and my vertex shifts here, and there we have the new one. Okay, so for this transformation, the original transformation occurred at 2. Since we shifted over, our new transition point is no longer at 2, it is now 1 over, it is at 3. So instead of having these, we need to change those from 2 to 3 because this got shifted. So it's now going to say x is less than 3 and x is greater than or equal to 3, just matching that. And then our x squared has this shift of 1, so it's x minus 1 quantity squared. And then this rule is x minus 1 plus 2. So here we could leave it like that, or we could simplify it and say that this bottom rule right here is x plus 1 for this right here. Put some commas to show that it's separated. Okay, next one. All right, here's our definition of a periodic function. This is an example here of a periodic function. Periodic function is one that the graph repeats itself identically over and over and over and over again. So it's followed as you follow it from the left to the right. So we see it goes down and then back up to right here, and then it repeats exactly the same shape at the same slope, everything over and over. Periodic functions have what is called periodicity, which means that they repeat at regular intervals. So there's a lot of things in the real world that have a periodic quality or periodicity, and these are things like clocks. Clocks have a period. They go all the way around every 12 hours and then repeat the pattern. A metronome has a period. You set it at a certain rate and it goes click, clock, click, clock, click, clock. And periodicals, they come out every so often, like a monthly periodical or a quarterly periodical will come out 4 times a year. So to describe the periodicity of a function more specifically, we define the period as the smallest shift possible that preserves the function's appearance. So basically, if I take this part right here that I'm tracing, it is exactly the same as this part that I'm tracing now in red. And so the distance from here to here, we would be able to shift this V, if you will, over this direction. How many units would I need to shift it for it to lie exactly on top of the other? Basically a translation like we did in geometry. Well, if I take this point and shift everything with it 1, 2, 3, 4, 5, 6, 7 units, it would match exactly that one. And so the period, or P, is 7 of this function. So that's how that works. All right, moving on to the next one. All right, now we've got some math notes here. Remember, it's in a big blue box. That means you need to put these notes into your math notebook and have it highlighted as, okay, here we have the information about sigma notation and how to use it. Okay, so this is the Greek letter sigma. It's equivalent to the capital letter S, and we use it in math to indicate sums, adding a list of things together. So it's a shorter way to write that so we don't have to write them all out. And so looking at this example, here's how it works. It's our starting amount is at 1, and then our ending amount is going to be at 3. So what that means is we're going to add the first, the second, and the third. If the starting was 2 and the ending was 10, that means we add together the second, the third, the fourth, the fifth, the sixth, the seventh, the eighth, the ninth, and the 10th. And that's what that part means. Next to it is the function or the rule. So this tells us what we're going to do with each of those. So the first one is what we get when we plug in 1 squared. And then the second one is 2 squared, and the third one is 3 squared, and that's where we end. And then we find the sum, and that's the simplified solution. So k squared is what's called the argument of the summation. That's and the k is the index. The index indicates the starting amount. And a k can only be an integer value. In sigma notation, we don't use like halves and things like that. It's always just integers. We have the first, the second, the third, the fourth, and so on, those terms. All right, so here's what we're going to do that. We're going to practice these. So this one tells us we're going to go from the third to the sixth, and this is already kind of done out for us. Here's the argument or the rule that we're using. So 2 to the, we put in place of j the 3. So 2 to the third power, 2 to the fourth power, 2 to the fifth power, and 2 to the sixth power. And to finish this, we put in the sum, which happens to be 120. So you have to figure out 2 times 2 times 2, and then add that to 2 times 2 times 2 times 2. You have to figure these out and then add them together. All right, so moving on to the next part, B. Okay, we're going from 3 to 5. So we're doing the third, the fourth, the fifth, and then that's it. And here's our rule, our argument. So we take the 3 and we plug it in for the n, square it, multiply by 4, add 2. That's what we see right here. And then it says dot, dot, dot. So we need to fill in the rest of it. So the next one's going to be 4 times 4 to the power of 2 plus 2. And then the next one, the last one, is going to be 5 squared times 4 plus 2. And we add that all together. So we have to calculate each of these separately. So it is a lot of math. It's a good thing this didn't say to the 10th power or something bigger. So that sum is 206. Okay, so this one, it has less done for us. So we're going to start with the first, go to the fifth, and we're going to take each one and do 1/2 to that power and multiply it by 16. So 1/2 to the power of 1 is 1/2, and times 16, 1/2 times 16 is 8. So there's the first number. 1/2 squared is what we do next. 1/2 squared is 1/4. 1/4 of 16 is 4. The next one is, so there's the first, there's the second. Now we're going to do the third. 1/2 to the third power is 1/8. 1/8 times 16 is 2. And the next one is going to be to the fourth power, so that's 1/16. 16 times 1/16 is 1. And the next one's to the fifth power, and that is 1/2 to the power of 5 is 1/32. So that ends up being 1/2. And you can see the pattern that's forming right here with all of these. And then we add them all together, and there we go. That's the sum. And that ends up being 15.5. Okay. So that's the same thing that we do here. Why don't you guys try one on your own for your notebook, and then I'll do this last one with you. Okay, so the first one, 1/1 times 1 plus 1. I'm plugging the 1 in everywhere there's an m. That's the first term. The second one is going to be 1/2 times 2 plus 1. The third one is 1/3 times 3 plus 1. And the last one is 1/4 times 4 plus 1. So we simplify all of that and then add it together. So let's see. We've got 1 plus 1 is 2 times 1. So this is 1/2. And then this one here is 1/2 times 3, which is 6. 1/3 times 4, which is 12. 1/4 times 5, which is 20. So we've got the sum of these fractions, and you can use your calculator or use what you know about fractions, but in the end it is 4/5. F, for part B above, identify the argument and the index. So in part B, the argument is this part right here, and the index is n. And there we go. So that's it. In a separate video, I'll give some hints and some notes on the homework. See you next time.